In this video, we are going to talk about how to assign the R and S configurations to a chiral carbon center. And to do that, we need to learn how to assign priority to the different groups, and then to assign that R and S configuration at a chiral center. All of this is called using the Cahn-Ingold Prelog convention or rules. Okay, so when we determine R and S, first we have to recognize that we do that at a chiral carbon or a chiral center. And you already are probably familiar with the idea that that means something, a carbon that is bonded to 4 unique groups around it. So the first step is that we need to identify our chiral carbon and the 4 unique groups around that carbon center. And we're going to start by only identifying the 4 atoms that are directly attached to the chiral carbon. So down here is an example. Our chiral carbon here, it's got 4 unique groups around it. I'm going to highlight the atom that is directly attached to that chiral center. Fluorine, chlorine, bromine, and a hydrogen. The next step is we need to figure out the atomic number of each of those 4 atoms. So we can go around like we know hydrogen is number 1. That's the atomic number of hydrogen. Bromine has an atomic number of 35. Chlorine has an atomic number 17. Fluorine has an atomic number of 9. Okay, so we would go around and we would figure out the atomic number of the atom that was directly attached, and then we need to assign priority based on that information. So I'm going to switch colors and do purple. The highest atomic number is the highest priority group. So it's actually the reverse of what you think. Hydrogen is number 1 for its atomic number, but that actually is going to be our lowest priority group. Bromine has the highest atomic number. That's our first priority group. So I'm going to say this is group 1, priority 1. This is priority 2. This is priority 3. Hydrogen is priority 4. So we use the atomic numbers, and then the highest atomic number gets the first priority. Go around and do that. The third step of all this is to make sure that the lowest priority atom is on a dash going away from us. And in this case, it very much is. We can see that right here. I'll highlight in yellow that hydrogen is on the dash going away from us. And then if it's not, we will have some strategies in another video to talk about what to do with that. And then finally, the last step is we just have to connect 1, 2, and 3. So I'm going to draw an arrow going from 1 to 2 to 3 and back to 1. The arrows that I'm drawing here are going around in a counterclockwise direction, going from 1, I'll show you again, 1 to 2 to 3, back to 1, 1 to 2 to 3, back to 1. I'm moving my cursor in a counterclockwise direction here, and therefore that counterclockwise direction, we call that the configuration around the center is S. Okay, if it was clockwise, we would call it R. Let's do some examples. So here's another example. So our first step is to identify our chiral carbon, usually denoting that with a star. And then I'm going to highlight the 4 atoms directly attached to the chiral carbon. That would be an oxygen, a bromine, a carbon, and a hydrogen. So we've done that. And now we need to work on assigning priority by identifying which have the highest atomic number. Oxygen has an atomic number of 8. Bromine has an atomic number of 35. Carbon has an atomic number of 6. Hydrogen has an atomic number of 1. But you got to remember that the highest atomic number gets the highest priority. So this is our highest priority. This is our second priority. This is our third priority. Hydrogen at the back is our fourth priority. And then we need to make sure that we've done steps 1 and 2, that our lowest priority group is pointed to the back. And it is. Our lowest priority group is this hydrogen. It is on a dash going back. You can look over on the picture of the model that I have here. I'm kind of highlighting on the model. You can see the hydrogen's going back. And then we just assign R and S from there by connecting 1 to 2 to 3. So I'll use my cursor. 1 to 2 to 3. 1 to 2 to 3. I'm moving my cursor in a counterclockwise direction. That will give us an S configuration. I'm going from 1 to 2 to 3. So now here's another example. What if there is a tie? So let's look and kind of work through this example and we'll see what we mean. So let's identify our chiral carbon. There it is. That's bonded to 4 unique groups. Okay. Here's our chiral carbon, and attached directly to that is this bromine atom, this carbon atom, this carbon atom, and this hydrogen. So you can see that we might have a problem now, because when we look at our, when we do the atomic numbers, the atomic number here is 35, the atomic number of carbon is 6, the atomic number of this carbon is 6, the atomic number of that hydrogen is 1. Well, it's very clear that this is going to be our first priority group, the bromine, and the hydrogen is our fourth priority group, but that carbon and that carbon are both 6, so how do we know which is which? We have to expand the structure out. And that's what the instructions on the far left here are showing us. So we would say this carbon is bonded to a carbon, hydrogen, a hydrogen, and another carbon. And we go out one atom at a time, one connection at a time. So we would see that, using my highlighter, this is our chiral carbon right here. I'll star that. That's our chiral carbon. And then going out one atom at a time, we saw this carbon and this carbon are the same. And then we go out from there. So hydrogen, 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 carbon. So this group over here, we found another atom, a carbon atom, that has a higher atomic number there. And so this group, the one I'm circling right here in orange, is going to be our higher priority group, because there is a higher atomic number directly attached to that. So when I'm assigning my priority here, this will have priority 2, this whole group, and this group here will have a priority of 3. And so our very last step is to go from 1 to 2 to 3, 1 to 2 to 3, 1, 2, 3. You can see I'm moving my cursor in a clockwise fashion. Clockwise is R, and that is because our least priority group is going back. So up here we can highlight that this is an R configuration. Let's do the next example. Okay, where's our chiral carbon? Here. And then we'll highlight the 4 atoms of the 4 groups directly attached to that chiral carbon. Oxygen, hydrogen, this carbon, and this carbon. We have the same problem again, that we've got a carbon and a carbon both. So when we assign the atomic numbers for these things, we know oxygen is number 8, hydrogen has an atomic number of 1, carbon 6, and this is carbon has an atomic number of 6. How do we make our choice? Well, we have to expand the structure out. So come down here. Here's our chiral carbon. This carbon off to this side, we're going to think of as being bonded to 2 oxygens and a hydrogen. This carbon over here, we're going to think of as being bonded to the 3 hydrogens that we can see more clearly. So when we go out atom by atom, here we can see this carbon is directly bonded to this carbon and this carbon. But then as we go out, hydrogen, 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 and then we can see over here, hydrogen in the orange, oxygen, oxygen. So this entire group over here that I'm circling in orange is the higher priority group. So when we assign priority, we're going to say that this oxygen up here is the first priority. This group is second priority. This group is the third priority because of the work we did below to expand that out. Hydrogen is the 4th priority. Now we need to check that our 4th priority group is going away from us. It is. Hydrogen is the 4th priority. It is on a dash going away. So we're all set to assign our R and S, and we go from 1 to 2 to 3, 1, 2 to 3, 1, 2, 3. I'm moving my cursor in a clockwise fashion. Clockwise is R. So we'll go up here and we will highlight that this is an R configuration. And this one was as well. So the last thing we need to talk about is what happens if our 4 groups on our chiral carbon are not explicitly shown. So you need to remember that if we just give you a structure like this with 1 dash, the hydrogen is still there at that spot. It's just implied. And so over here on the model, I've taken a picture of the model. You can see the oxygen's coming towards us and the hydrogen is there. It's just going away. So remember that you can still assign R and S even if all 4 groups are not explicitly shown. I'm going to pause the video here and I'm going to assign a configuration. I want you to do the same. So here I went through and I assigned the atomic numbers. I made sure my lowest priority was going back, and I assigned R and S from there. And this is an R configuration. Pause here and check your work.